homework from last night, how you guys were writing out a lot of those proportions. These proportions basically will set you up throughout the rest of this entire chapter, knowing how to work with proportions. Remember, a proportion is just two ratios that are equal to each other. One of the easiest ways to think of this is 3 over 4 is the exact same thing as 6 over 8. 3/4 is the simplified version of 6/8. Now remember when we talked about this on Monday? I don't remember what day it was. It seems so long ago. When we worry about checking to see if things are a true statement, if these are true statements, we would be able to cross multiply and get the same thing. So 3 times 8 is 24, and 4 times 6, hey, look at this, is also 24. So proportions are ratios that are equal to each other, which means that if you cross multiply, you get the same number. Okay? Now, what happens today is that we throw in a couple of properties that deal with ratios and proportions. By moving a couple of values around, you still get what are called true statements. It really isn't difficult to see, or it really, it's not that I'm going to have to ask you guys to show why all this stuff works, but it's an idea that you guys are going to use this because we utilize the moving of values within proportions to solve basically equations. And that's what these wind up working out to be. So if I look at the next one, if I say 3/4 is 6 over 8. Watch what happens if I flip-flop those two. What I mean by that is I'm going to change the ones on the diagonal. Is that a true statement? Yeah. That's a true statement because 3 over 6 is what? It's a half. And 4 over 8 is also a half. It's still a true statement. So what happens is you are allowed to exchange these on the diagonal. It still creates a true statement. Same thing if I went the other way. If I said 8 over 4, isn't that the same thing as 6 over 3? If I switched them the other way. Yes, ma'am? What'll happen here, probably not so much today, but over the course of the next few days when we start working with the actual similarity statements that are within triangles, we're going to have variables in a bunch of different places. So we're going to have to see how can you manipulate some of the proportions to be able to solve for x. That's all. There's ways around it. You don't have to memorize these things. It's just showing that it works. Okay. I know. Because Bella, what will happen here is eventually we could have x over 4 is 6 over 8, or we could have 3 over x, which is 6 over 8, or we could have 3 over 4, which is x over 8, and so on. It's going to move itself around, so there's going to be different ways to make it work, to get x by itself quicker. We okay with that? So it allows you to change things on diagonals. Okay. Forgot the other property was off the top of my head, but hey, the bruiser's back.
Yay! Someone broke their ankle yesterday.
Yeah, Hoppy. Pray for my boy, Hoppy.
Austin, did you see it?
Yeah.
Did you hear it?
And I remember
He broke his ankle wrestling? Was it practice or?
Yeah.
Ooh, that's gross. Here, take 2.
I didn't show any pictures of Austin.
Paper.
Good job.
You get better at wrestling to be in the paper.
Ooh. I am good at wrestling.
And then the other one that's a little bit weird. Thanks, Austin.
He says you're not welcome.
The other one that's a little bit weird is if you take the denominator. The denominator is always the number in the bottom. guys remember that, right? If I take that and I go 3 plus 4 over 4, and 6 plus 8 over 8, you can add the denominator to the numerator, and as long as you keep the same denominator, it's still going to work. Because what's 3 plus 4? 7. And what's 6 plus 8? 14. If you look at that, what does 14 over 8 simplify to be? 7/4. It's double. Okay. So the three properties that we basically wind up looking at is that you can switch them on diagonals, you can flip them, you can bop them.
Wait, you can flip them. You didn't say that.
Oh, I didn't say that one? Oh, I skipped that one? Sorry. So
They keep having me. And they're so ugly.
if I flip them,
They're ugly.
same thing, isn't it? If you think about, when I say if I flip them, that just means you switch the diagonals twice. Think about it. If you flip them, you switch the diagonals twice. You went from 3 to 6 is 4 to 8 by switching these two. And then if I switch these two, I get 8 to 6 is, 8 to 6 is 4 to 3. It's the same thing. So you can flip them and it still works. Okay? As long as whatever, remember, numbers are jealous. Whatever you do to one side, you have to do to the other. Okay? Flipping something is actually what you call an inverse property. Did you know that? You guys ever, in Algebra 1, did you guys talk ever about exponent rules?
Yeah.
Like x squared, x cubed. Did you guys ever talk about x to the negative 1?
Yeah, you gotta
Yeah.
look at the bottom.
Exactly. And that's what this means. If I take, anytime I flip a fraction, that means the entire fraction is unhappy. The whole thing would have to be flipped. So if you use properties, it's the same thing as basically sending that exponent to both parts within the fraction. So it's another way of saying 3 to the negative 1 over 4 to the negative 1. Who's not happy? Both the 3 and the 4, so that's why they have to flip. That's why that works. Okay? We use inverse properties a lot later. Okay? There's a whole section on it in Algebra 2, which I think I start Friday. It's exciting. Yes, sir?
Says like beginning the algebra 2, they're gonna start ways.
Yeah, we just got done not only doing the inverse exponent rules, we actually do them with fractional and radical exponents as well. Nth roots, fractional roots, it all works the same. It's just the same exact properties as x squared, x cubed, same base, different exponents. You'd add them together. Same thing if it's a fraction, you just add fractions. So that's kind of what we're in the middle of doing right now in Algebra 2 in my class. The other algebra classes are getting there. I'm about a chapter ahead. So basically then, what you guys will be able to look at are problems like this to try to figure out what did they do. Yeah. If they start out with 6 over x is 5 over y, then, well, they said that the first thing you did was put 6 over 5. What's the other one have to be? X over y. Very good. Because you're looking at what you started with. You started with this as your proportion. The next thing said, hey, let's take the 5 and put it here. Which means what had to go here? What didn't move?
Why?
There it is. That's it. It's looking at the problem to figure out what did it just do. It's kind of like a fill-in-the-blank proof. What did you just show? Oh, I showed the additive property of equality. Oh, I showed angle addition. So on. Okay? That's kind of where we're at. Same deal with the one on the bottom. The one on the bottom started with the x over 4 and the 7 over y. Well, what did they do to the first fraction? They added the denominator. So what do you have to do to the next one?
Add the denominator.
add the denominator. So it would just be 7 plus y over y. Make sure you caught that. That's it. What's that? Done. We're almost there. This is just to kind of get you used to how these things are going to move within the properties. Now what happens when we go to algebra? I'm getting ahead of myself here. No, I'm gonna do this. This is where we start to get into what are you going to do when you have to work with a given statement. Today, they're going to start by giving you the proportions. You don't have to quite come up with them on your own yet. We will learn how to do that over the course of the next week or so, because there are certain properties that allow you to do this. Put it in your pocket, Riley, thank you. So, what's that? Thanks. So what happens here is what we're trying to get through is we're trying to get the idea of how it's going to work by using algebra with fraction equal fraction. For some reason, this is one of those things that a lot of students have a heck of a time remembering how to work with. So that's why they kind of slowly go through it in this 6-2? Yeah. So you're going to be given a triangle, you're going to be given some sort of a figure, and they're going to tell you what your proportionality statement is. Fill in the blanks. That's all it is. Okay? To start a lot of this stuff is to fill in the blank. So what's A over B? Or, I'm sorry, A over B. What's AB? 6. So you have 6 over X. Yeah, you can just call it X. You can say BC, it doesn't matter. Just call it X. It's easier. And what's AE? And what's ED? Okay, cross multiply and solve. What do you get? And you're seeing that because you're simplifying it. That's fine. 6 times 4 is 12x. And you get 2. Of what? Simplifying it out? Sure, you can do that. If you recognize it, by all means, there's nothing wrong with doing that, because if you see that 6 is half of 12, well, what's half of 4? 2. Or 12 over 4. How do you turn a 12 into a 6 without subtraction? Remember, we're going to multiply. You divide it by 2. You take half of it, so it has to be. And then you can always check it, because what's 2 times 12? And what's 6 times 4? 24. You get the same thing when you cross multiply out, which means you didn't done goop, and you're all right. Right? It is quite literally fill in the blanks today. Be all right. Same deal. Same deal. We have a triangle. They give us a, what do you want to call it? Not similarity, we're talking about, they give us a proportionality statement. Very close to being a similarity statement, but we're not quite to describing those yet. And they give us values. It's a matter of filling in the blanks again. So according to the diagram, what's AB? 12. You write it down. 12 over something. AE is the 18. But what's ED then? 15. Very good. Notice, sometimes you will have to try to figure out what a chunk is by either adding or subtracting or working through it. They told us the whole segment. That's all it is. Okay. Again, cross multiply and solve. 18x is 12 times 15. Means you'll divide by 18. Well, let's see, that would be a 6 and a 9. This would be a 2 and a 3, and that would be a 5. So yes, it is 10. 180 divided by 18 is 10. Thanks for paying attention. Very good. All right. Take a minute. Actually, no, we'll skip this. Let's go to this one. Let's go to this one where things get to be a little bit goofier. If you have to do a little work. What's that? No, what'll happen is when we start to get into more of the similarity portion of this next week and whatnot, we'll be able to prove that triangles are similar because of certain properties that have them. So it's basically, if you know the property, then you can say it's similar. It's kind of the same idea as you can show that something's a right angle or a right triangle by showing the Pythagorean theorem works. You're not doing a proof, but you're going to do algebra to show that something works. That's how it works. Yeah, don't worry about proofs. We're done. Except for final stuff. Feel the same when I talk to you. I don't know. Oh, this, yes. Yeah, that is a 6. Sorry. Yeah, that's 6. Now, when you start going through one like this, they're gonna, again, they're giving you the statement to start with. They tell you have BD over DA, BE over EC. Which means you just have to fill in the blanks. Okay? Now, BD is that much. I don't know what that much is. But if I know from here to the door is 10 feet, and I go 3, how much is left? 7. What'd you do? You subtracted. So if from here to the door is X amount of feet, I take away 3, how much is left? That's all it is. You have the whole chunk. You take out 3, that just means you took out 3. If the whole thing is the whole value, the whole segment is X, if this much of it is 3, that means you took out 3 of the whole thing, which gives you the X minus 3. That's where people tend to start to get a little messy about, are you adding something in, or are you subtracting something out? We okay on that?
Yeah.
Yes, sir.
Yeah, do that like reverse, and then gives you X minus 3, and then gives you 3,
Exactly. And we'll see more and more of that as this gets more complicated in a few days. Okay? So now it's just a matter of filling in the blanks. BD was X minus 3. DA, 3. 18 over 6. So you have to cross multiply again, or in this case here,
Can't you just like,
can I simplify that one?
yeah.
Do I have to?
No.
No. We all have calculators, so it's okay that we don't. But I see right away that 18 over 6 is
3 over, or 9
3.
over 3.
What?
It's 3.
It's 3. You were simplifying it by 2, then you'd have to go another step. So you weren't wrong, but
Yeah.
make it easier.
Just not simplified enough.
Right. You're almost there. So I'm going to say that this is X minus 3 divided by 3 equals 3. Do I have to put over 1 though? Because now, when you work backwards from solving an equation, you have junk divided by 3. How do you undo divide? Multiply. Multiply both sides by 3. And you get X minus 3 is 9.
So
What?
X is 6. I mean, no, X is not 6, X is 12.
X is 12. I did, you know what? I did the exact same thing first hour. I wrote 6. Yes, sir.
Are they doing all that? Or is it just like,
Can you go back up?
What do you mean do it quicker? Is there anything wrong with doing it that way? No, there is not. there's more than one way to do these problems. Okay? All it was that I recognized that 18 divided by 6 is 3, and it was just easier because I wasn't using the calculator. Right? That's the way I was looking at it. What you did was not wrong. Yes?
I got 9 because 6 divided 6, 3 is half, 6 is half of 3, and 1 time is
But it's 9 minus 3. So we're going with that? You're not wrong. You're not wrong with the way you're trying to set up. You're trying to find the pattern in the number. You got to take into account you had that subtract 3. So if you want to think of it that way, what minus 3 is going to be half of 18. Okay. Again, that's about as goofy as this stuff gets today. Okay? We all right on that? All right. Yeah, I'll let you figure out the estimate. It's easy.
Wow, I thought that was actually.
No. We're not that far ahead. No 6 problems for you. Sorry, you get a couple more. Yeah, but these first groupings are, if it's 6 over 5 and x over y, what happens when it's 6 over x? What's the other one? So it's really, really, really fast. It's just to get you guys used to the properties and some very quick cross multiplying. Okay. Get those things going for tomorrow. We'll talk a little bit more about it tomorrow. I don't know if we'll have how much time we will have to start 6-3. We might be able to start a little bit of it, which shouldn't be so bad. It winds up being more of the same. It's more how do you write out a similarity statement and just fill in the blanks. So it's just a matter of letters, really. Okay, just like it was with congruencies. How do you figure out what's congruent to what? Well, you write out the statement. Same deal. Okay. I should get those tests back in your hands as well tomorrow. We should have time to do that. You want to start at flex today? Yeah. It's all right. I'll give you one. I didn't want to kick you out on this one, so I wanted to see a little bit of this because we'll probably do more of it tomorrow. So if you spend 20 minutes, I just take off one of the pages, then I can have you finish it tomorrow in class. Okay. Sorry. What's that? What? What's that? Here, man. What do you want? You want to buy one? I gotta get some more out. Yeah, give me 1 second. I'll go grab one.